All right. So let me erase this part. Sorry about that, folks. The projector just screwed up. I was thinking it was a projector. I thought it could be something coming there. Okay, so we've gone that far. The last thing we did was x squared and a negative x cubed. Plus will go into minus, minus times. X squared goes into x cubed, x times. So what's the next step? Multiply. Negative x times x squared would be negative x cubed. Very good. That's what we wanted it to be. Okay? Next, negative x times negative 2x is plus 2x squared. And negative x times positive 10 is minus 10x. Okay? Now what do we do? It's either subtract or change signs and add. That's a Q there. I don't know why it looks like a 2. Okay? All right? Which you like? Can you subtract it like this, or you prefer changing signs and adding? I think change signs and adding is usually good. Make that a plus, make the next one a minus, and make the next one a plus. Okay? Now add. The x cubes go away. What about x squareds? A little louder. Negative 6 x squared. Help me, help me. Plus 12x. Anything else? Negative 60. Very good. Now what? No, divide. X squared and the negative 6x squared will go how many times? Negative 6 times. Now what? Multiply. Negative 6 times x squared is minus 6x squared. Minus 6 times negative 2x is negative, positive 12x. You're right. Positive 12x. And minus 6 times plus 10 is negative 60. And I think you can look at that and tell you when you subtract that or change signs and add, that's everything going to 0, which you knew it was supposed to be. If this was a 0, you knew that 1 minus 3i is a 0 from the rule we did last time that nobody was here for. Okay. And then if those two, the product is, well, the product of those two is this. That's what we calculated first. And now we know that's the other factor. Well, what can we do with that one? We're looking for all the zeros. We know that's a 0. They told us. We know that's a 0 because the coefficients were real. That has to be equal to 0 is a solution. So therefore, what you do here is factor this. And how do we factor that? X squared minus x minus 6. Oh, these are fun, aren't they? You used to hate them. Now they're so much easier than the others. How do you do that? Okay, obviously the x squared factors is x times x. Where do we look next? The sign of the last term is negative, so that means these are 1 positive, 1 negative. Okay? And you want two numbers that multiply to be 6, and the difference, because these are different signs, be a negative 1. In which order? 2 with the plus, 3 with the minus. Check it and make sure. Let's see if it is. X times x is x squared. Good deal. Minus 3x plus 2x would be minus x. Yes. Minus 6. Yes. We got it. So, if those are our factors, what are our zeros? X equal negative 2 or x equal positive 3. You got it. Okay? Those are our two remaining zeros. They gave us 1 because you had real coefficients and that was complex. Its complex conjugate was the second one. And then multiplying those two together give us a factor. Divide that factor into the whole polynomial and get another factor. See if you can factor that further. We could. That gave us our last two zeros. Does that make sense? All right. Now, is that how I would have done it? No. It's just how they gave you the problem given what they had to begin with. There is a checkpoint here, and again, it has an imaginary component, so I'm going to try to avoid those on the test, but you need to be at least familiar with them. So let's move on. Oh, let me erase all this, and let's see if they did it any differently. I think not, but let's just see. Because the complex zeros occur in conjugate pairs only when their coefficients are real, they are. So then you know that if this is a 0, which they told you, then that has to be a 0 because all the coefficients are real. Now once we have that, we know that x minus the first one and x minus the second one have to be factors. If those are zeros, x minus the thing is a factor. Okay? So the next thing they're going to do is multiply those together. And they choose a strange way of doing it, but it's perfectly correct. They notice here that this is an x minus 1 plus a 3i and x minus 1 minus a 3i. So what they do, now you have to be careful with that. To me, their technique is fraught with danger, okay? If you separate out the x minus 1 here and put it together, what you've done is remove this parenthesis. When you remove the parentheses, this minus also goes in here too. That becomes a minus 3i. So that's why that became a minus 3i. And here, x minus 1 here, and then you have minus a minus becomes a plus 3i. So it's fine to do it this way, but to me, you're more chances of making a sign error. And frankly, when I'm grading papers, Math 100, 112, just about any of my math courses, even calculus, I found more errors in signs than I do in the heavy stuff, the hard stuff. So I don't particularly care for this method, but just another way that works. So now we have the sum times the difference of the same two entities. Comes out the same. It just, at this point, may be a little shorter. X minus 1 times x minus 1 is x squared minus 2x plus 1. Okay, that's just a square of a binomial. And then this would be minus 3i squared. So I squared is negative 1, so that would be plus minus 3 squared, I squared, and 3 squared is 9. I squared is negative 1, so that would be plus 9. So this is what you, well, they wrote it out. This would be x minus I squared, x minus 1 squared, minus 3i squared, which would be 9i squared. Okay. They're doing it correctly. It's just a weird way to do it. And then they skip a bunch of steps. This is x squared minus 2x plus 1 plus 9. 1 plus 9 is 10. X squared minus 2x plus 10. So that's your product of your first two factors. Then you take that and divide into the original polynomial, just like we did. They scooped down the quotient, which is fine. There's nothing wrong with it. But since you're using it over here, I like to put it here. But you can put it over there if you want to. X squared into x fourth is x squared times x squared times x squared is x fourth. X squared times negative 2x is minus 2x cubed. X squared times positive 10 is positive 10x squared. Okay? Then they subtract. Now, they don't change signs and add, but when you subtract, let's just go over that. X fourth minus x fourth is obviously 0. Disappeared. Okay? Minus 3x squared minus 3x cubed minus 2x cubed, that would be minus a minus is a plus, so that would be a minus x cubed. 6x squared minus 10x squared is pretty obviously negative 4x squared. Bring down to plus 2x. Divide now. X squared into negative x cubed, negative x times, that's why I like to have it over here, negative x times x squared is negative x cubed, negative x times negative 2x is positive 2x squared, negative x times positive 10 is negative 10x. When you subtract, obviously those go away, and then this would be a minus 4x squared minus a positive 2, minus the positive is negative, minus plus minus 6x squared. 2x minus is minus 10x, minus is positive, so that gives you 12x plus 12x. Bring down the minus 60. And finally, x squared in the minus 6x squared is minus 6 times. Minus 6 times x squared is minus 6x squared. Minus 6 times negative 2x is positive 12x. Minus 6 times positive 10 is minus 60. And then when you subtract those, obviously everything goes to 0. So that meant these indeed was a factor. There's a factor. We knew how to factor this. That's why we got it. X plus 3i, x minus 3i. There are two zeros. X minus that. I said that wrong. X minus a 3 plus I and x minus a 3 minus I. Okay. This is a factor. So let's see if we can factor that further. And that's what they do next by saying, well, they wrote it down. Good for them. Okay. Then they factor this further to be x minus 3 times x plus 2. Just like you did. Now, since you have the factors, you can conclude that the zeros here, where they told you this was a 0, we knew that would have to be a 0 too. This tells you x equals 3 is a 0, and this tells you x equals negative 2 is a 0. That's what we were looking for. Time out and step back one step. What if their question had been not find the zeros, but factor that big old hairy polynomial we have without using any complex numbers, imaginary parts? This would be the complete factorization with no imaginary parts. This is what they call relatively prime in the real system. You can't factor this any further in the reals. You can using complex numbers, imaginary parts, but you can't anymore. So if this had been the question, your answer would have been, that is the factored form, these are the zeros. Now I'm going to try to avoid the i's, because, we technically aren't, it's not in our course description to do those, though I'm showing you how to do them in case you ever need them. But that's what you got. Okay. Any questions? That was example 7. And in that example 7, without being told that 1 plus 3i is a 0 of f, you can still find the zeros using synthetic divisions to find the real numbers that. Now, last time, I'm trying to remember, when we met last time, when people were here, did we go over rational zeros test? Okay. I hope you listen to watch YouTube because it's on there. Okay, so please watch it. What you do is use that rational zeros test to come up with these possible zeros. You'll come up with plenty more, but you come up with those. Once you find one of them, then keep finding, and then when you get it to this form, you see there's no more real zeros. You got it in completely factored form. Now, if you use a quadratic formula on this, you'll find your radical contains a negative number, and that's where you get the i's from, here and here. Okay, so you can still get it the other way. I will try to avoid those if I can, and keep them in real numbers. Okay, that was example 7. They're skipping example 8. Let's go back and do example 8. Okay, I think this is probably the best place to do it. Write f of x is equal to x to the 5th plus 3x cubed plus 2x squared minus 12x plus 8. Let me make sure. Yeah, we did do rational zeros. Yeah. Okay. Now, Y'all weren't here. Hopefully someone listened to it. Does anyone know how you would begin this problem? It says, okay, again, the question says, write that as a product of linear factors and list all the zeros of the function. So we're looking both for the factors and for the zeros. Okay? How would you begin? Anyone have an idea? Okay. Say again? I still can't hear. Okay, yeah, you definitely need a placeholder for the x fourth term. So we're going to do that when we get to the point of doing it. You're absolutely right. Okay? Good catch. Okay? But how do we begin to find either those zeros or factors? That's what we're looking for. The what?
Set it equal to 0.
Okay, yeah, ultimately you are, but what were you going to do after that? Okay, yeah, you want to try factoring that? Knock yourself out. Okay, here's a technique I talked about last time when nobody else was here. Okay, 12:30 Tuesday, remember? We moved it from 12:30 last Thursday because more people could be here 12:30 Tuesday, remember? Okay. What's that?
I showed up Tuesday.
And didn't stay around for the real class at 12:30? Huh? Oh, okay. Well, we talked about it all week last week. Okay. Here is the technique. Okay? We find all the rational zeros, possible rational zeros of the function. Rational means ratio, fractions. And here's what we have. They show up as P over Q. Why they use these letters, I'm not sure. What are P's? P's are all the possible factors of your constant term. What are all the possible factors of 8? Plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. All the possible factors of 8. That's all, folks. Okay? Now, what's your Q? That's all the possible factors of your leading term, leading coefficient. And what's that? 1. So what are they? Plus or minus 1. So basically, that's all, folks. Those are your possible zeros, rational zeros. Because you put them over 1, you got them 1. Okay. Now here's the second thing I told you. I like to start and do it as easy as possible and see if I can find a 0. Okay? The easiest one to choose here is plus 1. So let's start with plus 1. Now, plus 1 is easy because if you put a 1 in for x, that becomes a 1, that becomes a 1, that becomes a 1. 2 times 1 is 2. That becomes a 1. Minus 12 times 1 is minus 12. Guess what? It's your coefficients. Let's add them together, see if we get the 0. That's what you said. It has to equal 0. Here's 1 plus 1 is 2 plus 2 is 4 plus 8 is 8 and 4. 12 minus 12 is 0. Bingo, we have a 0 right there. That's why 1 is so nice. X equals 1 is a function, is a 0. I'm saying things backwards. X equal 1 is a 0. Okay? And by the way, what would be the factor corresponding to that 0? X minus 1. Right? Because if x minus 1 is equal to 0, x equal 1 is your 0, right? So, as soon as you know a 0, you know a factor. All right, so we're going to take that 1, and we're going to do synthetic division. Do y'all remember that one? Did we do that last time? Last time y'all were here? I think we did synthetic division, didn't we? Okay. So, what we go here is your coefficients. So, give them to me. 1, 0, excellent. 1, 2, negative 12, 8. Now, I take a time out here and go and count my numbers. How many numbers we got? 6. What's your exponent? 5. It's got to be one more than that. You got it. Good. What's the next step? My little rule? Skip a line, draw a line. Very good. Then what? Drop down the 1. Next. 1 times 1 is 1. Next. 0 plus 1 is 1. Next. 1 times 1 is 1. Next. 1 plus 1 is 2. Didn't know you'd be doing such high-level math today, did you? Okay, 1 plus 1 is 2. Okay. Next. 1 times 2 is 2. Next. 2 and 2 is 4. Next. 4. 1 times 4 is 4. Next. Negative 8. Next. Negative 8. Next. 0. Bing, 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 bing. That means we do have a factor. We knew it. We had already plugged it in. We knew it's a factor. What does this represent, though? The quotient. Yeah. This is x to the 4th plus x cubed plus 2x squared plus 4x minus 8. That's your quotient. But guess what? That's the factor of that one. Because this was a factor, this is a factor when you put all those x's in there. So guess what we do again? Let's add those coefficients again to see if we still get a 0. Because that 1 could be a multiple root. So let's see again. 1 plus 1 is 2 plus 2 is plus 4 is minus 8 is 0. Hey, we can do it again. Do another 1 into that. Now that only works for plus 1. If it was a minus 1, you actually have to do the synthetic division. But the plus 1, you can just add coefficients. Only one you can do that way. So what do you do now? Skip a line, draw a line. Bring down the 1. Or drop it. Okay, yeah. 1, 2. 1 plus 1 is 2. You need to practice that one. Okay. All right. 2, 4, 4, 8, 8, 0. Ding, 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 ding. Another winner. So not just x equal 1 is a 0. It's a second 0. X equal 1 is my other 0. That means x minus 1 squared is going to be a factor. Okay? Want to try one again? If you added those together, you're going to get a 0? No way, they're all positive. Okay? Can't. Now, I'm going to give you a hint. We haven't gotten there yet. We're going to get there in a page or two. When you're dividing synthetic division and you're doing positive numbers into this, if you wind up with all positives down here, it's not going to do you one dab of good to try plus 2, plus 4, plus 8. That's the largest positive number you're going to have is a 0. We haven't gotten there yet. That's called the upper bound test. So what I'm going to tell you right now, forget about plus 2, forget about plus 4, and forget about plus 8. Don't even try it. They're not going to work. Okay? We'll get there in a minute, but you'll see it's true. So the next one I would try would be my minus 1. So let's divide by minus 1 and see if that might work. Now, I'm out of room, so I'm going to do it over here. Minus 1 into 1, 2, 4, 8. Okay, skip a line, draw a line, and do what? Bring down the 1. Minus 1. One. Minus 1. 3. Minus 3 ain't going to work, is it? Okay? Forget about minus 1. Okay, that didn't work. All right, so we'll erase minus 1, erase this, and erase that. Okay, I've already told you, I shouldn't have, but I did, that you can forget about the plus 2, plus 4, and plus 8. Because you had, so let's go to minus 2. Let's try that one. You bring down the 1, and then that gives you minus 2, 0, 0, 4, negative 8, 0. Bing, 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 bing. We have another winner. x equal negative 2 is a 0. What would be the accompanying factor? X plus 2 is the other factor. Very good. These factors go together. These zeros go together. Okay? Now, once you get to three numbers here, what does that represent, by the way? X squared plus 0x plus 4. That's a quadratic. Stop there. Don't try synthetic division anymore. Now, Tyler can factor. He's been wanting to factor all along, right? Okay, so let's write this as x squared plus 4, and like you said before, equals 0. Can any of you tell me if that's going to work? Can you factor that? Huh? What you get? The chart ends here. You are? Okay. Any ideas? What do you think of when you see x squared plus 4 equals 0? It's what? X minus 2 times x minus 2, is that what you said? Okay, try it and see if it works. Ain't gonna work. If you're meaning x equal minus 2, if that's what you're meaning, minus 2 squared is positive 4. 4 plus 4 isn't 0 either. In other words, there's no real solution. You cannot factor the sum of two perfect squares, only the difference of two perfect squares. So guess what? That won't give you a real solution. It will give you a complex solution. In fact, two of them. Okay? And by the way, how many zeros we are anticipating? Up to 5. We've got 3, because 1 counts twice. Okay? We're missing 2. Here they are. 2i and minus 2i. They always show up in conjugate pairs. Those are our zeros. Okay? Now, I'm just as happy not to mess with the i's, but those are your last two zeros, x equal 2i and x equal minus 2i. And x equal 1, x equal 1, and x equal negative 2. Those are our 5 zeros. Let's write that in completely factored form. You've already got 3 of the factors, x minus 1 squared times x plus 2, and then, frankly, leave this as your final factor, x squared plus 4. And that's equal to this, okay? That's as far as I'm requiring you to go. The book probably is going to factor it and say x plus 2i times x minus 2i. Yeah, those are factors as well, but I just assume leave it as x squared plus 4. Leave it real factors, real coefficients of factors. So this is example 8. What they wound up with is the zeros, x equal 1, x equal 1, x equal negative 2, and like I said, x equal plus 2i and minus 2i. I'm not as concerned with those. And in factored form, x minus 1 times x minus 1, or you can write that as x minus 1 squared, times x plus 2, and then you can write it as x minus 2i times x plus 2i, or just leave that as x squared plus 4. That's perfectly fine. All right, any questions on that? All right. I think that's all of that one. Now let's do some other tests for zeros of polynomials. Frankly, team, here's what you're doing. When you got big, powerful polynomials, big number of exponents and stuff like that, you use every trick you can get. One really handy one was rational zeros. We just showed that, okay? Then synthetic division using those rational zeros, okay? Here's a couple of more techniques we can use. The first of these is Descartes' rule. Okay. You know that an nth degree polynomial function can have its most, how many zeros? Nth degree polynomial function? n zeros. It will have exactly n complex zeros. It can have up to n real zeros. Okay? Of course, many of the nth degree polynomials don't have n real zeros. They have something less than that. For instance, this one. What's the n here? 2. How many real zeros do you have? 9. Both of the zeros here are complex. What's your maximum? What's your number of real zeros here? Maximum number of zeros you can have here? 3. Are any of them real? Yeah, 1 is. -1. -1 cubed is -1 plus 1 is 0. The other 2, complex. Okay? So this one has no real zeros. That one only has 1. Okay? So, and -1 happens to be that one. The following theorem, called Descartes' rule of signs. Now, time out for a commercial break. Papers. Research papers. Now this class, I think, so far is my best class yet at getting in papers. I have 1, 2, 3, 4, 5, 6 out of 25 students originally. We don't have quite 25 in the class anymore. We lost 2, so we're down to 23. 6 out of 23 is not bad, not as good as it should be. So please, folks, think about your papers. Start working on your papers. You have a day off tomorrow, right? Think about your papers. Okay. The reason I say that now, Descartes' rule of signs, who in the world was Descartes? Okay, that would be a good paper topic. How did he develop this rule of signs? That would be a good paper topic. How do we use this rule of signs? Now, you can't use the book for it. You'll have to go elsewhere, but that would be one. And there's lots of other good paper topics as well. Choose something, get the writing. Okay? But Descartes' rule of signs sheds more light on the number of real zeros of a polynomial. Really now, we're putting tools in our belt to figure out how to determine those zeros. And here's what Descartes' rule of signs says. Here's your f of x. A sub n is the leading coefficient. A sub n times x to the n. A sub n minus 1 times x to the n minus 1. Plus, you keep counting down. Each one has a coefficient. You count down on your exponents. So you get a2. The subscripts here for the a's are just indicators that they're different coefficients. Okay, these are just coefficients. A sub 2 times x squared plus a sub 1 times x to the first plus a sub 0 times x to the 0, which is 1. Okay, that's a polynomial with real coefficients. Okay, if you have complex coefficients, don't use the Descartes rule of signs. But if you have real coefficients, yes, it works. Most of ours, in fact, all of ours, I think, will have real coefficients. Here the deal is the a sub 0 cannot equal 0. This cannot be 0. We already know that a sub n can't be 0 because then it wouldn't be an nth order polynomial. Okay, so those are not zeros. Okay. Now here's Descartes' rule of signs. It seems so simple. Would you say, how in the world could this be true? But it is. The number of positive real zeros of F is either equal to the number of variations in sign of F. So if you start counting down here, if this is a plus and that's a minus, that's a change of variation. That's a change of sign. If that's a minus and the next one's a minus, that's not a change of sign. And then when you get to the next plus, there's another change of sign. When you get to the next minus, there's another. So you count your variations in sign. Okay? So it's either equal to that number or less than that number by an even integer, 2 or 4 or 6 or 8. So that's how we start with the Descartes rule of signs. That only gives you your number of positive zeros. Possible. The second thing you do then, the number of negative real zeros, because that only gives you positive, is either equal to the number of variations in sign of f of minus x. So the next thing you do is plug in a minus x for an x, rewrite the polynomial. Okay? And once you've rewritten that, count your number of variations in sign then. It's either that number, or subtract 2 from it, or subtract 2 from that. You keep going down. That's what you got. Variation in sign means that two consecutive coefficients have opposite signs. Now, to me, this description is blah, 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 okay? It's a lot of words, and they really aren't easy to understand. Either this or that, or decreased by this. When you actually do them, I think you'll find they're much easier. When using the Cart's rule of signs, a zero of multiplicity k should be counted as k zeros. So if x, that last one that we did, x equal 1 is a 0, but it was a double root, so you count it twice. X equal minus 2 was another 0, that's a negative. Okay. For instance, this polynomial, okay, you tell me, just look at this polynomial, what can you tell me about the number of signs? Number of zeros. There's one change of sign. There's another change of sign. So you have either 2 or 0 positive real roots, right? Okay. Now, if you're going to see about negatives, you put a negative x in. What does that become? If you plug a negative x in for x, cube it, what do you get? Negative x cubed. If you plug a negative x in for x here, you get plus 3x. That gives you a change of sign, right? Negative to plus. Then that's a plus that you don't have, so you only have one negative 0, okay? You can't subtract 2 from that. You've got to have one negative 0, at least one negative 0, okay? So this shows you have either 2 or no real zeros, positive real zeros, and the other one tells you have at least one negative real zero. Well, if you were to take your rational zeros test, what would those zeros be? Plus or minus 1 times plus or minus 2 divided by plus or minus 1. Well, that's just plus or minus 1 plus or minus 2. Let's try plus 1 first. That's the easy one. Just add your coefficients. Does that give you a 0? 1 minus 3 plus 2. Or 1 plus 2 is 3 minus 3. Yeah, that gives you a 0. So you know you got a positive 0. Once you find out you got one positive 0, x equal 1, you know you've got to have another one. Okay? Because it's either going to be 2 or none. You don't have none because you found 1, so you got to have a second. So you do your synthetic division on that. Let's go on and do that. Sort of a fun problem. How do you do that synthetic division? You found out that 1 is a 0. What do you go into? 1. Second? 0. Good. Negative 3, 2. Skip a line, draw a line. 1, 1, 1. Y'all are stuck on ones, aren't you? Okay. Negative 2. Negative 2. 0. We knew that was going to work because we plugged it in. But what does this tell you? What does that give you? What does that represent? A quadratic. What is it? X squared plus x minus 2. And you see what happens if you set that equal to 0. Now, Tyler wants the factor, doesn't he? Yes. What does this give you? X times x minus times plus minus 1 plus 2. Check that. Sure enough, that works. So there you have 2 more factors. If you have those 2 more factors, and by the way, this gave you that x equal 1 was a 0. What factor goes along with that? X minus 1 is your factor. This gives you x minus 1 is a factor. What does that give you as a 0? X equal 1. So we have a factor of x, another x minus 1, and another 0 of x equal 1. And then this gives you as a factor x plus 2. That gives you as a 0 x equal negative 2. And guess what? Our Descartes rule of signs said we'd have one negative 0. We got it. 2 are 0, we got 2 positive zeros, 1 and 1. Okay? So sure enough, we found all the zeros, x equal negative 2. 2 positive zeros, 1 negative 0, and we found there are 3 factors at the same time. Good deal. So you can see that the 2 positive real zeros are x equal 1. So you could write that as, if you were factoring, they've written it there, or you could have written this as x minus 1 squared times x plus 2. If you want to be really lazy about it, you could do that. Okay. 2 positive real zeros, x equal 1 and x equal 1, multiplicity of 2, 1 negative 0, x equals negative 2. Descartes' rule of signs told us we'd have either 2 or none, positive, 1 negative. We found the negative, we found 1 positive, so we knew we had to keep looking to find the second one. Good deal. All right, here's example 9. Determine the possible number of positive and negative real zeros of that polynomial. So let's start with the positive. What's the maximum, or what is the positive number of real zeros? How do you get it? Count your sign variations. 1, 2, 3. 3 positive, I'm going to write it here, 3 positive real zeros guaranteed to be for 3? No. 3 or, no, 1. Subtract 2. 3 or 1 positive real zeros. Now, the good news in that, you do have 1. Guaranteed to have 1. You can't get by without 1. Okay? Next part of Descartes' rule of signs says do what? Alpha of number of negative real zeros you get from alpha of negative x. So you go back here and do alpha of minus x. And what would that be then? Negative 3x cubed minus 5x squared. Why? Because when you square a minus 1 or minus x, you get a positive x. So that doesn't change sign. Here's a hint, folks. If you got an odd exponent, you change the sign. If you have an even exponent, keep the sign the same. Right? Because negative times negative times negative changes the sign. Negative times negative puts it a positive. Okay. So that's a minus. How about the 6? Negative 6x, negative 4. That has no x's in it. How many sign changes? 0 negative real zeros. So guess what? When we do our rational zero test, forget about the negatives. You can't, not even worth looking. Don't test any. Descartes' rule of signs says you have none. You may have, you're going to have 1. You may have 3 positive real zeros. See, it gives you more information so you can make your life a little easier later. Well, that just gave you the possible number. What you would do next is Descartes' rule, rational zeros test. We're not going to do it. All I asked for is possible numbers. We got that answer. But you would do plus or minus 1. Except forget about the minus. You know you don't need a minus. 1, 2, and 4. Those are your numerators. Your denominators are 1 and 3. So you got 1, 2, 4, 1/3, 2/3, and 4/3. Those are all the possible rational zeros. You don't need to do plus or minus because you know the minuses aren't going to work. The easiest one of those would be 1. You just Add your coefficients. 3 plus 6 is 9. Minus 5 minus 4 is minus 9. There, you got it right now. You know at least that 1, positive real 0 is going to be a 1. Then you do what? Synthetic division. Do 1 into that thing, see what you get left. That you get left is going to be a quadratic, right? The question will be a quadratic. See if you can factor it or get a Tyler to help you, okay? And if it factors, you got your other 2. If it doesn't factor, you only had the 1. See? Made life easier. Thank you, Descartes. What else is Descartes known for about? How is he otherwise known? Very famous thing he did. What do we call that thing? Yeah. We call it a graph, right? It actually has a name, a Cartesian graph, named after René Descartes. He came up with that. He was the first one to make the link between graphing algebra and geometry. Graphs are usually geometric. They thought algebra and geometry had nothing in common with each other. And he brought them together and found out they're both fields of mathematics. Thank you, Descartes. He's also quite a philosopher. Okay? Do any of you know his most famous quote? To me, it's his most famous. I think, therefore I am. That was René Descartes. A lot of his philosophy, he was French, a lot of his philosophy kind of made its way over across the ocean, and I think Thomas Paine, Common Sense, remember that back in the Revolution? And several of the others used a lot of Descartes' philosophy in coming up with the groundworks of American democracy. France didn't have it yet, but they used Descartes and others, many others. Okay, quite a character. Okay, let's see how they do. Oops, hit the wrong key. Okay, let's see how they did it. All right. The original polynomial had plus to minus, that's 1, minus to plus, that's 2, plus to minus 3. Variations in sign, that told us that we either had 3 or, well, they didn't say it, did they? That told us we either had 3 or 1 positive real roots. Next thing we did was plug in minus x instead of x, f of minus x. So we do 3 times minus x cubed, minus 5 times minus x squared, plus 6 times minus x, minus 4. If you want to do all this, you can. This makes this minus raised to the third power is negative. Negative raised to the second power is positive, but you already had a negative, so it's negative, negative. And then minus times plus is minus, then a minus. So you have no variations in sign. They all turn out being minus. So that tells you have 0, absolutely no negative real zeros. So don't even look for it. So from the Descartes rule of signs, the polynomial of this has either 3 or 1 positive real zeros and absolutely no negative real zeros. So then you use that fact when you then go back to doing your rational zeros test and everything else. And we picked out that 1 right off the top because x equal 1 made that work. Okay? When you draw the graph, you see it was just 1, not 3, because it never crosses again. Okay? Make sense? Okay, it almost sounds like, are we? Oh, we do. How many? 2 more. Okay, let's see. Another test for polynomial functions related to the sign pattern of the last row. This is what I gave away earlier, synthetic division. That test can give you an upper or a lower bound of the real zeros of f. A real number c, that if you do c into your synthetic division, is an upper bound for the real numbers of f when no zeros are greater than the number c. Okay? Similarly, c is a lower bound when no real zeros are less than c. Okay, they're just giving you the definitions of them. Here's where it comes into play. If f of x is a polynomial with real coefficients, remember if you have complex coefficients, hang it up, Jack. We don't have it. And a positive leading coefficient. Oh, there's one more thing. You have to have that positive leading coefficient. Suppose that f of x is divided by x minus c. In other words, you do synthetic division with c into that thing of f. Now it just requires that first one to be positive. If that c is greater than 0, in other words, a positive number, and each number in the last row, that quotient row down there, is either positive or 0, then c is an upper bound. Don't look any further. Remember before we found x equal 1 was the upper bound. Don't look any further. If c is less than 0, in other words, that's a minus 2 or 3 or something like that, you're doing synthetic division. And then the numbers in the last row are alternately positive and negative. Plus, minus. 0 entries count either as positive or negative. Then c is a lower bound. So if that last row, if you have a negative inside, dividing, and the last row alternates signs, then that c is the lowest bound you can have. You can't get any smaller. All right, good deal. Let me give you a few homework exercises. I know you want some. You don't want to have this long weekend with no homework. What's that? Okay. Any of the odds 9 through 13, either 15 or 17 or both. Any of the odds 19 through 27, either 29 or 31 or both. Either 33 or 35 or both. 37 or 39 or both. 41 or 43 or both. Don't worry about 45 to 49. Those have I's in them. 51 or 53 or both. 55 or 61 or both. 63, I'm sorry, any of the odds 55 to 61. Any of the odds 63 to 79. Any of the odds 81 through 85. Then using Descartes' rule of sign, any of the odds 87 to 93. And upper and lower bound, you can try some of those, 95 or 97. If you can't do them, we're going to do examples of that later. All right, good deal. Yes? You both need a quiz? Okay. All right. This is quiz 2, right? You need graph paper. Okay. Here's quiz. There's quiz. Both of you need graph paper. Okay. Here's graph paper. And here's graph paper. There you go. Good deal. All right. We will see you next week. Have a good Veterans Day. Probably by this time tomorrow, we should be well into Georgia, maybe even close to Atlanta by now. My wife said we're going to get an early start. Yeah. All right. Have a good weekend.